Hello! This is Jose Luis here at Parametric Camp, and welcome to a new video in this series, Advanced Development in Grasshopper, where I would like to teach you how to implement persistent data in native Grasshopper plugins. And by persistent data, I mean data that stays there across different updates, multiple updates of a Grasshopper component. And this is useful if you want to do things as, for example, a counter that every time I update the component gives me a new amount, a new number for how many times the component has been updated. Or if I hit play, I can see this number increasing over and over again for every update. It requires a small trick, which is handling where that data is living inside of the Grasshopper plugin. But it's actually a really common technique for things such as simulations, dynamic simulations. So let's talk in and let's get hands-on and let me teach you how to do this. Let's get started. So if you remember in our previous video where we implemented permanent state using C# script components, which by the way you can check, there should be a card popping up somewhere here, or there should be a link in the description of this video. If you remember from the previous video, we discussed that if we want data to be persistent across different iterations or across different updates of the component, one trick that we need to do is that instead of declaring data or storing data in the main body of the function that takes care of executing whatever the component is doing, what we need to do is we need to add that information, the variables that are going to contain that persistent data, we need to declare them and maintain them outside of that function. Because if you remember, because of the rules of scoping variables in computer programming, whatever you declare inside of a function expires as data whenever that function finishes executing. And if you want to learn more or refresh what scoping in functions means, we also have a video about variable scoping that will pop up in a card, and there will be a link in the description of this video as well. So what we need to do is, because this at the end of the day is a class, is an object that gets instanced and that has a particular function that gets executed when the component needs to update. If we declare variables outside of that function, what we are indeed doing is declaring fields, declaring variables that belong to the class. And whenever that class gets instantiated as different objects, aka in this case different components, each one of those components will have variables that belong to that specific component and that are not shared across components and that are persistent across cycles of execution. That was the logic for C# script components. Well, it turns out that in native, if we do this natively in Visual Studio, it's pretty much the same logic. Because if you remember, if we go back to Visual Studio, what we're doing when we create a component is that we're taking this Grasshopper component class, we are subclassing it, we are creating a child instance, we're inheriting all of that, but we're basically doing the same thing. We have here a bunch of functions that are specific for declaring inputs, declaring outputs, and the one function that we typically use to solve the instance, or where we actually put the code that is going to run every time we execute this component. Well, it turns out that the principle of moving whatever data we want persistent across updates, moving that data outside of this function, that same principle also follows. So the only thing that we need to do is we need to make sure that data is declared somewhere outside of this function. And because this is a class, we can just declare fields for this particular class that will belong to this instance of a component whenever it's dropped on the canvas. So for example, what I can do is I can declare a variable here, and I'm going to call this persistent fields, or I don't know if it's persistent with an E or with an A. I'm going to call this, for example, updates, which is going to be initialized to 0 whenever the component is dropped. So with this, I'm going to keep count of how many times the component has been updated. And then what I'm going to do here is that I'm going to take and retrieve the input that so I have already pre-declared here two inputs. One is going to be the ticker, and one is going to be a reset, just like we had in this exercise here, right? And then, but remember, the ticker is just an input that we use to trigger an update, but we don't really care about its value. It's just for the sake of forcing Grasshopper to update this component. And what we want is to output the number of iterations, the number of updates that this time, I'm going to call these updates, the number of times this component has updated. So the way to do that is every time we solve this instance, we're just going to take the number of iterations, or sorry, the number of updates, and I'm just going to increase it by 1 unit. And then through the update, through the output, I'm going to say day set data in position 0, and I want to output updates. All right, this number here. And with that, we should be good to go. So I'm going to close this. I'm going to close everything, and I'm going to trigger my Grasshopper plugin, and I'm going to open Grasshopper automatically, and it's loading some stuff, and the file already shows up. Okay, the main file that I'm using for debugging here. So if I now zoom out, I should have here on the PC, I should have a new category that I've created called development. And I have this folder, this component called counter, the one that I just created, right? It has the ticker, it's just generic, and a Boolean, which is the reset, which we will implement very soon. And this is the amount of updates that this component has taken, all right? So here, what I'm going to do is I'm going to plug a Bologna, a random input, okay? And it looks like it's not working because parameter R didn't collect any data. So let me just plug in a Boolean toggle, all right? And actually, this should be a Boolean button, all right? Which is not going to work right now. But you can see that as I move my ticker, right? Every time I move my ticker, one new input data gets fed to the component that triggers an update, and the number of updates just goes up. All right? So it's the same principle. Now, the only thing that I need to do here is now make sure that I use the reset value as well. So for example, I can do that by saying, well, if let me first fetch that data. So Boolean reset equals false. And then let me, if this, then reference reset, and then if reset is true, then updates should be equal to 0. Okay, I'm going to run this, see if it works. Okay, I'm going to drop the component because I forgot to save this. I'm going to drop the component again. I'm going to drop a reset button, and I'm going to place here a panel. And so I got this, one updates, all these updates, etc. And then I can reset this, okay? Reset, and then updates. You may note that as I reset, I get the number 1, and I'm still pressing the button. And when I let go, I get the number 2. That's because letting go, when it goes back to false, still triggers an update. So maybe if you're annoyed by this is technically true. But if you're annoyed by this, what you can do is you can set this to -2, for example, so that when you let go, the count ends up at 0, if that's what you're interested in. And you can also, if you remember, you can also use a trigger. So what I can do is I can connect the trigger here. I can set an interval, for example, 100 milliseconds, and hit play. And you can see how this trigger is basically ticking my component, and it's updating it every 100 milliseconds, all right? Updating this count. So this is, long story short, the only thing that changes when you want to do persistent data across updates, and you're doing this natively in Visual Studio, is that you need to remember that the fields, the persistence field, are basically fields that you add to the class that is representing that component. So you just add it as a field here. Nothing really different about this. Now, one thing that it's cool that you can do if you do native development is that if you want for some reason to make these updates automatic, right? Like for example, in the previous exercise where we were doing simulations, physics simulations, and you're kind of bothered by the fact that you have to force this one component, the ticker, the trigger, to update externally, there's an option that you can use, which is you can actually write code to have the component update itself. So the component be the one who is triggering or it's ticking himself at regular intervals, which is something that is actually quite cool. And it's something that we're going to see in the next video. In the meantime, thank you very much. And if you liked what you saw in this video, maybe hit the like button, subscribe to the channel, etc., etc. Otherwise, see you in the next video where I will explain how to implement auto updates in native Grasshopper components. Bye bye.